All right, we're going over pH and acid-base characteristics. Many household items are acids and bases, and that'll probably be what we transition to after quarter one. So acids, these are compounds that start with hydrogen, and you can ignore this. So usually hydrogen is bonded to what we call an anion. You'll remember that. It should be a negatively charged thing, usually a nonmetal, or what we call a polyatomic ion. So note the property of an acid. So this is HCl. H is with Cl, so the positive H with the negative Cl. When I put it into water, the H and Cl separate. So I get this positively charged hydrogen and this negatively charged chlorine. Call it a hydronium ion. So the example would be HCl, when I put it into water, separates. Now acid properties, these are listed on yours. They have a pH below 7. I'm not going to necessarily read through all of these, but I might mark it up a little bit here. pH below 7, they're sticky, sour. They're in fruits like lemons. They produce H+. They turn blue litmus paper, which is a paper to test, red. And they start with hydrogen. That's the biggest thing for us right now. And that's not a perfect example, but it is what it is. Bases are compounds that end with OH. So instead of H with acids, I get OH with bases. H plus OH gives me H2O. So when I put a base into water, I get sodium and OH dissociating or separating. Okay. So examples would be right here. So properties of bases, opposite of acids, pH above 7, they're slippery, bitter. They're in cleaning products. They produce OH. Instead of red, they're blue. And they end with OH, and they end with OH. That's the biggest thing down here. So you could watch that video if you wanted to, but pH scale is a logarithmic scale, which means every time I change a pH of 1, so if I go from 7 to 6, the concentration changes by 10. So what we'd say is pH of 2 is 10 times more acidic than 3. And if I went from 11 to 13, we'd say a base with a pH of 13 is 10 times 10, 11 to 12, 12 to 13, 10 times 10, or 100 times more basic than a pH of 11. So on my pH scale, you'll often see these little brackets around it. That means concentration of that ion or how much you have. So the concentrations are equal at pH of 7. So I have H and OH equal numbers. That's called H2O or water. So anytime I go down in pH, my concentration of hydronium increases, and anytime I go up in pH, my OH minus increases. So make sure you get that onto your pH scale. So think about this, and let's talk about it. Where is H plus the highest? Where's OH minus the highest, and where are they equal? So H plus is the highest down here. OH minus is the highest down here, and they are equal right at 7. So true or false, pH of 11 is more acidic than 13. 11 is more this way, so that is true. pH of 4 is more basic than 1. It's more that way, so yes. Concentration range of 11 to 13, that's 2, so it's 10 times 10. That'd be 100. And 1 to 4 is 10 times 10 times 10, or 1,000 times. So last thing, when an acid and base are mixed together, the H plus and the OH to form water. So what you'd see is that this H here and this OH here produce water on this side. And they join up. But then what's left over is this Ba and this Cl, the cation and anion, cation positive and negative, so they form what we call a salt. So that's BaCl, in this case 2. And you don't have to know those yet, but that is a foreshadowing of where we're going with chemical reactions. So what we say then is when an acid and base react, the products will always be a water and salt. So to write the formula, crisscross the cation and the anion to form the acid. We won't really worry about that now, but remember those words crisscross. We also say that an acid neutralizes a base or a base neutralizes an acid. So what that means is that a low pH of an acid and a high pH of the base when mixed together tend to move together towards a pH of 7. whichever direction it is. So we got homework here. What would red litmus paper turn? Remember, this is when added to milk of magnesia. Milk of magnesia right here is pH of 10. It's a base, so red paper would turn blue. And red litmus paper, I put it into tomato juice, which is right here, pH of 4, that's an acid, would stay red. Oops. Red. Okay, so why don't you finish that one? According to this graph, which is 100 times more basic than seawater, so more basic is moving this way. So seawater's here, 100 times means pH of 1, pH of 2 change. That would be milk of magnesia. I'll just put M of M. Okay, once you try to answer those. And then the last part, you're doing the characteristics of acids and bases. So like based off of our lists on these pages. Right, like right here, properties of acids. And that's it, guys. We're done. All right. Love you. Talk to you soon. Bye.